My name is Siamak Paulson, and welcome to this episode of my podcast. As you can see, I have a special guest in this episode. Professor David Williams is my guest. David, welcome to this episode, and thank you for accepting my invitation today.
Thanks, Siamak. A pleasure.
Thanks a lot. So I normally start with a quick question about where in the world you are. I know you're in the same city, or you live in the same city that I live, Brisbane, Australia. But where in the world you are today?
Right now, I'm actually in Brisbane, so we're in the same city, same time zone. That hasn't always been the case. I've done a lot of traveling, particularly the last year, and that looks set to continue.
That's right. That's right. Very good. Nice. So, David, I just want to start with the normal question I ask all of my guests about their career. Can you just maybe start by telling a little bit about yourself, your background, and specifically, how did you end up in tailings management and in the tailings industry and mining industry?
Okay. Well, I'll go back to the beginning. So during my last year or so in high school, I was thinking about, what profession I might head towards, what university. It was always taken for granted I'd do university. It was just a question of what in university I might do. And I eliminated a few things. Medicine didn't appeal to me. I don't like the sight of my own blood, let alone someone else's. So that didn't appeal. I didn't think of law, for example, and I'm actually quite happy I didn't go down that route. I thought about geology. I talked to a geologist about the possibility of getting in that field. So I had an interest in the earth, but I felt geology was a little bit too narrow. And I then talked to a civil engineer who's actually more in the water area. And he was the one that turned me more onto the idea of doing civil engineering. So when I started engineering at university, it was always going to be civil. Not that interested in cars and moving parts, so not mechanical. If you think about electrical engineering, it's about electrons moving around. It's on too small a scale. So I like the scale of civil because it's a scale that you can see, you can visualize.
Yeah.
So that was decided. And then what turned me on to specializing a little bit in my degree, my first degree on geotech, was really both my best lecturer and my worst lecturer were actually in soil mechanics. But it was the one who was my best lecturer who turned me on to the idea of soil mechanics. That was Ian Donnell. He's the late Ian Donnell. Very clever man, quite inspiring. So that sort of set that direction. I did a thesis in soil mechanics, had an interest there. My first degree was supported by a cadetship from the then Country Roads Board of Victoria, like the main roads department in Victoria. It's had several names different to that since. So that gave me a route into employment with them. But I did holiday work with them and so on, and I felt that was a little bit too restrictive. To be honest, I didn't think they'd give me enough work to keep my curiosity at bay. So I then pursued the idea of possibly doing a PhD somewhere, and I thought, let's do that overseas, combine that with overseas travel. So I started making inquiries. Long story short, I ended up, I needed a scholarship support. I managed to get a Commonwealth scholarship, and I ended up going to the UK and studying at Cambridge University. That's where I did my PhD. Mm-hmm. So that opened up a wider world, if you like. I came back and I was fairly keen at that stage to join a consultancy, though I had a bit of an entree to Golder at the time and ended up working for them. For about 3 years, I had a year and a half or so in Melbourne, and then which is where I grew up, and then they transferred me to Brisbane. And then there was the 81-82 downturn, and the only option within Golder was to move to Sydney. At that time, the cost of housing in Sydney was about 4 times the cost of housing in Brisbane, and we just bought a house in Brisbane, so that wasn't really an option.
Who was in Brisbane Golder office? Rob Morphy or someone?
No, it was Rob was there, but he was quite junior at the time. It was more Len Walker was the one that ran Golder out of Melbourne. Bob Amaral was Sydney. I had less to do with him. People like Ian Smith, who then transferred to Perth, and then for a while was in Brisbane. It was that sort of vintage. Scott Fiddler is later. Yeah. And Kevin Rosengren, he was in Melbourne when I joined. He moved to Brisbane. I later moved to Brisbane, so I was there as well. So it was more that vintage. But particularly, others that had a big influence were Marcus Kazim. In those days, different from now, you would write a report, probably longhand to start with, and it would be vetted by someone. And Marcus Kazim was the main one that went through my reports, and he literally used a red pen. And it wasn't just a case of, it's not like today where you get track changes. And if you're lazy, you just accept all the track changes.
Accept all.
You actually have to go in and change things and then get it typed. So it was a much slower process. So I'd attribute a lot of my training in terms of report writing to Marcus Kazin, because he did a very thorough job of leading me through that. Others were Jack Morgan, also ex-Melbourne Uni, came back to Golder. So some of my projects were with him. Probably the most were Marcus, and then Jack, and then probably Len. They were the three main people I worked with. That was very good background. And interestingly, that my PhD was actually on piles.
Oh, yeah.
Related to the offshore industry in the North Sea at the time. And so my basic training was civil with a geotech bent. My PhD was very much geotech. But once I joined Golder, I started getting involved in mine waste management.
Yeah.
And that was both in Melbourne and Brisbane. And really, that's been the mainstay. Having joined the university, I then mainly did work in the application of geomechanics to mine waste. So waste rock dumps, spore piles, tailings, covers, closure, the geotech side of all of those things. So that really set the pattern. And at the university, I've been at the university now 41 years. I'm about to retire, April next year. It'll be close to 42 years when I retire.
Yeah.
So it doesn't seem like that long. It's a long time, 42 years, but it's gone quickly, and your role changes as you progress through your career.
Yeah.
So it's been a very rewarding career, and I will continue in a consulting capacity. I'll still be already been appointed emeritus to the university, so I'll still have some connection there and still get engaged in some of their activities. But primarily, I'll focus on consulting, and I'll do that for, I don't know, the next 5 to 10 years. See how that goes. Absolutely. I might eventually retire.
No, that's very, very fascinating career you had, David. And like you said, mine waste and tailings management, this has been really a key and a highlight, I think, in your career. So just wanted to ask you about the direction that tailings management in general is taking these like last few years, and especially after the GISTM. What do you think? What do you think the tailings management? Which direction do you think it must go, or it must be going, and which direction do you think it's actually going?
Yeah, I don't think it's that complicated. It's not rocket science. We simply need to build stable dams. We've had an excessive number of tailings dam failures. We've killed an excessive number of people. It's done immeasurable damage to the industry, not only the mining companies, but also the consultants who work for them, the contractors who work for them. Everyone associated with that has sort of been tarred by that failure rate, which is, by anyone's measure, excessive. It's just too high. So I liken it often to, you think about a high-rise building. What would be the design life for a high-rise building? And you could ask engineers, and they're a bit confused about what that might be. Some will say 50 years, someone might say 100 years. They rarely say anything longer than 100 years. We don't have too many high-rise buildings in the world that are older than 100 years. What happens when they reach that? What does that mean? Do we pull them down and start again? Well, some of the older, less high ones might be pulled down. They're being pulled down already and replaced with bigger ones or higher ones. That might happen, but it's not going to happen across the board. So why is it that the building industry has got away with a design life of 50 or 100 years, but tailings has now moved to 10,000 years, effectively, because they're there in perpetuity, tailings facilities, whether it's a tailings dam, waste rock dump, or whatever. So we've got to that point because of loss of trust and confidence that the industry will do better, that their designers and contractors will do better, that the regulators will regulate, and make sure that they do better, we've lost confidence and trust that that will actually happen. So the end result of that is they've upped the effective return period for loading. And the two prime loadings for tailings are obviously flooding, but also, which is most pertinent in particular in Australia, or seismic, which is less pertinent in Australia, but over a 10,000 year period, seismic is still a factor.
Yes,
We still need to account for it. So you need to account for both flooding and earthquake loading. So I think build stable dams is the approach we should be adopting. If you build a stable dam, and you might argue, the industry might argue too, that, well, that's expensive to build a stable dam. You can offset that cost by dewatering the tailings so they occupy less volume behind your stable structure. Then your stable structure either lasts longer or doesn't have to be as high to store the same amount of tailings. So I often go to sites and I ask them, can you tell me what percentage by volume is water in your tailings deposit? And most of them have no idea, because they work in terms of mass typically. But the specific gravity of water is 1, and the solids might be 2.8 or whatever they happen to be, almost 3 times as much. When you think of it in terms of volume, then the water component, the water proportion is much higher. So for a typical metalliferous mine, it's about 50% water. So half the height of the dam is to store water. Now, you're not going to eliminate all water, and you're not going to have no void space that's clear. Even rock has 5 to 10% void space. But you could reduce it from 50%. It doesn't have to be that high. So there could be potential large savings in terms of how high the dam needs to be. And then you can afford to make the dam more stable. In the worst case, if you think about oil sands tailings or red mud from bauxite processing, if you don't do anything to make it denser, it will typically be about 85 to 90% water by volume. So the majority of your dam height is to store water, not to store solids.
Yes.
We need to think about that. We need to correct that. So I think the basic thing is separate the containment from the storage, make the containment stable, a reasonable level, and I'm not saying unreasonably stable, a reasonable level of a reasonable margin of stability, higher than some of the dams that we currently have. And then think about containment, think about storage, So store in a way that minimizes the volume that is taken up. That's where I think we need to go. There are some steps towards that. We're getting increasing pressure to look at filtration, so dewatering tailings by filtration. Not all tailings can be easily filtered if they're too fine, or even if they're too coarse. If they're too coarse, then they probably don't need filtering anyway. They'll drain fairly well. But if they're too fine, they're difficult to filter. So that's one move. But there's no silver bullet. There's no single solution. And I think you still need those basic principles. Build a stable dam and maximize your use of that dam by putting the tailings in as dense as you can. So we've still got a long way to go. It's very difficult to retrofit an existing operation and change it from whatever the practice is now to something different. Now, it's difficult, it's expensive. You've already made the commitments and the investments to do it a different way. So it's difficult to do. And then you look at regulation. So in most of the world, they're not mandating a particular tailings management option, except for Brazil. So Brazil, because of their 2 failures, and in particular Brumadinho, the more recent one, which killed 270 people, they're mandating through the law, you must do X, Y, and Z. So you must not go upstream. You must, they call it decharacterize. You must remove unstable dams, at-rest dams, including all the tailings. You must do that remotely because of the risk to personnel if you do it any other way. The other problem in Brazil, though, is I feel that the regulators are loath to give extra footprint, to give a permit for more land, which means that inevitably their storage, whatever the storage is, has to go up. It can't expand laterally. That's a recipe for disaster, I think, in the longer term, because you can't keep going up. There is a limit to how high you can go. So while regulation in Brazil has brought about some good things, I think it needs to be coupled with the regulators grasping the nettle and think in terms of we need to permit more area so that we're not reliant on just going up. Because you could filter tailings, you could compact them, but if you make that stack high enough, you'll render it liquefiable. Still need a trigger, but the trigger could be an extreme rainfall, wet season rainfall. It could be that. It could be an earthquake if there's happened to be one sufficiently high to cause that to fail. So we've still got some challenges. So the GISTM has certainly done a lot to improve governance. Excuse me. But I don't see it's done a lot so far to change the way we actually manage tailings, except in Brazil. But in Brazil, it's not driven by GISTM, it's driven by the law, which is a response to the failure that killed 270 people.
Yeah.
It's not hard to imagine why they did it, but it's a different mechanism.
Yeah. Well, I wanted to ask you about GISTM, and also, like, you mentioned recent failures, specifically the ones in Brazil. You kind of answered that question for me, but happy to elaborate on that if you like, but also maybe focus on another very important issue we have in tailings management and in the mining industry, and that's training, education, and basically the engineers coming to this field. What do you think about that? What needs to be done, and is what's happening now enough, or what are your thoughts on that?
Yeah, I think training in any specialty, tailings is just one area, training in any specialty has become problematic.
Yeah.
We traditionally rely on universities to provide that basic training. Universities are not able to financially support niche areas, smaller areas. If you think about, just take one centre, Brisbane, and you think about the University of Queensland, just one university, they're not going to attract in one centre, Brisbane, enough people with an interest in tailings to pursue a degree. That's simply not going to be enough. So the only way to address that really is online. You need to increase the size of the audience or the reach of your course. And universities have not done a lot in that area. There are a few standouts. There are some universities that specialise in online. They're not the mainstream usually. They're more the regional universities are doing this. And they're not the ones that would necessarily have the expertise in specialist areas anyway. So universities are not well equipped to address that need. It's not just tailings, it's lots of other specialties as well. They're focusing more on the core engineering disciplines of civil, mechanical, electrical, chemical, not so much the niche areas. So someone needs to step in and provide online courses so they can broaden the audience to Australia-wide or even internationally to attract a number that makes it a viable course. And there's certainly demand for that. So in my case, one of the highlights of my recent career was to initiate and largely run the AusIMM, that's the Australasian Institute of Mining and Metallurgy course. It's a professional course, development course, if you like, with assessment. And it's been run now since 2020, 10 times. We've attracted a global audience. A total of about 1,200 people have gone through that course. It's probably I think it is the most successful course of its type in the tailings management space. There are some other courses. Andy Free runs a course out of UWA through the university. Mine is through AusIMM, not through a university. There are courses in the US. There's a consortium called TailEng that runs a number of courses as well. The offerings are fairly limited. There's also UBC has a course on mine waste management as well, a master's level course. So there's a small number of offerings around the place, but I think that's where it's going to come. It's going to come out of those courses, and maybe they'll extend over time as well to a greater range of courses. And it's not intended to make you an instant tailings engineer. It's more intended to give you an awareness of what the issues are, provide the learnings of my career and other people's careers in tailings management, what's important, what sort of things do you need to look for, and where to find it, give an indication of where to find those skills and so on. And then the rest of it is really on the job.
Yeah.
It's training through engagement in tailings management. I mean, for me, I can say my involvement in tailings in particular, but mine waste in general, and the geomechanics of that, has been a very fulfilling career. It's taken me around the world. It still takes me around the world.
Yes.
Given me a very exciting and interesting career. That's the sort of opportunity other people could pursue as well.
Absolutely. Absolutely. Well, the course is available in English, I guess, and I just heard something about Portuguese. Is that also happening, or
Yes,
is it just a handbook?
We've run it 10 times in English.
Yep.
And we ran it in the last session. So we do, in recent years, we've done 2 a year. And in October, November this year, we also ran the same course translated into Spanish. That was run by a colleague of mine, Hernan Cifuentes. He's Chilean originally, but based in Brisbane.
Yep.
So he and a few other people got involved in that course. Marcelo Lano was another one. And also Angelica Andrade from Brazil. Her sister was tragically killed in the Brumadinho failure.
Yeah.
And she's taken a keen interest since in that approach. So she talks about the social responsibility, social performance side of mine tailings management. So it has been run very successfully once in Spanish, and I think that will continue. We're looking down the track at running it in Portuguese to cater for the Brazilian audience. So it's really just the idea is to expand the reach. In a recent ITRB, Independent Technical Review Board meeting in Chile, we gave the presenters, it's a bit embarrassing in some ways. I go on some of these international boards. I'm the only one that can't speak some other language. I can only speak English. So they're somewhat obliged to present in English. We report in English and so on. At this most recent meeting, we had very good translators, real time, and they were technically trained as well. So they were able to translate in various technical terms. And we allowed the speakers to speak in whatever language, well, Spanish or English, whichever they were more comfortable in. And this was very successful. It meant that you didn't get problems of communication through, problems of translation, because we catered for that. The presenters were much more comfortable presenting in their own language. We coped with the translation. We'll still report. Actually, what they did was the PowerPoints were in English, but they presented in whatever language, Spanish or English, that they preferred. Yeah. It worked very well. So I think we can broaden our reach to other parts of the world by catering for other languages, Spanish, Portuguese in particular, to cover Latin America. And then it also covers parts of Europe as well. You could consider other languages too, but that's a starting point. Spanish first, Portuguese in a year or so's time. So that broadens the reach of that course even further.
Absolutely. No, that's a great course. So as my last question, David, I want to ask you to think about 2 other people that you think should be my guest on this podcast. And then whoever you nominate, you should put us in contact with them as well.
Oh, I can do that. Well, I mean, my field is tailings, so I'd probably nominate some of the up-and-comings. Peter Chapman is one I'd nominate out of WSP in Perth. So there's a batch there's sort of a generational gap. So if you think about Naughty Morgenstern is about 20 years older than me. And then there's about a 20-year gap back to the next lot that are coming through. And it takes, almost need to be grey-haired and maybe balding as well and older to be selected for some of these boards that are formed for tailings. But there's a need for transition. There's a need for succession planning, and the next batch coming through need to be brought into the system. So I'd nominate Pete. I'd nominate Hernan Cifuentes.
Oh, yeah.
My colleague out of, so he's living in Brisbane. He's now launched his own consultancy. And the other one I'd nominate is Marcelo Lano. He's with Red Earth Engineering in Brisbane. So Marcelo, actually, I first came across him. He was completing the last year of his PhD at the University of Queensland. He'd started at the University of Brasilia. He's from Colombia originally, but he was studying his PhD in Brasilia. Did the last year in Brisbane. I kept him on as a postdoc, for a couple of years until the money ran out. And then he joined first KCB and then went on to Red Earth. Very capable engineer. All of those people are very capable engineers, and it would be nice to, this is part of the succession planning, to start promoting the next generation. And if you think in terms of, what are your memories, what are your significant memories of a career well spent? And I'd say a large part of that is mentoring. Being able to engage with and advance the careers of people that go through you as students. So Pete Chapman and Hernan were both PhD students of mine. Marcelo, I only got involved with him after his PhD, but as a postdoc. And I keep in touch with all of them very closely, and it's great to see them progressing through their careers and so on. And they're the ones that'll be the future.
Absolutely, yeah.
The rest of us will fall off the perch eventually. We need to nurture the next generation coming through. So they're probably the three that I know. I could nominate more, but they're three that come to mind. I mean, one more I would mention too is Rob Longy, GHD Hobart. Rob's, again, a very capable tailings engineer, very passionate about doing it well. And I've come across him both through work in Tasmania, through GHD in Hobart, but also the Didipio site in the Philippines, which Rob is the engineer of record for. Does an excellent job there. So he's another one that it would be good to see that new batch or the next batch promoted, so they get more in the fore and they get more used to talking to a wider audience.
Absolutely. No, that's perfect. That's perfect. And David, I'll finish with just a quick note about 42 years of your time. It will be 42 years next year, I think, as you said. The University of Queensland, I guess, like I personally have worked with a lot of graduates coming from UQ, and your name is always, and obviously in geotechnical field, is always there. And I just wanted to thank you for basically educating the generations of geotech engineers that are working in Australia or elsewhere.
It's an interesting facet because it's often one to many. So I might give a lecture to a group of people, and that group of people all think that I must know them because I've just lectured to them.
Yes.
So I haven't bothered to count how many undergraduate students that I've taught, or how many. I don't even know exactly how many PhDs I've supervised either. It's not really important, but it's a large number. And one of the gratifying things is to be at a presentation or whatever and have these people come up to you and say, "Oh, you taught me in such and such."
Yes.
They might say you probably don't remember me, and that's probably true. But it's gratifying to have people come up to you and say, you're known because your face has been in front of presentations and so on. You've been doing it for a long time. In fact, Marcelo once asked me, what makes someone famous? And I said, basically doing something that you're passionate about for a long time. And then you become known, and the longer you do it for, the longer you'll have exposure to people, the more you'll become known for that particular area. And it just happens organically over time. It's not something you can manufacture, but it takes decades.
Yeah.
It's not something you get in 10 years.
No, absolutely. That's perfect. That's perfect. All right. Thanks a lot, David, for your time today. That's what we have time for. And wish you all the best with your future consulting and travels and everything you do.
Yeah, and the same to you, and Merry Christmas to everyone.
Merry Christmas to everyone. Thanks a lot.
Thanks, Dan.